Hello, everyone. Welcome to the web track at Scale. So I'm Tom from Facebook. I'm going to be the MC for this track today. First of all, thank you, everyone, for coming out. I'm actually super excited about a lot of the talks that we have here, but we'll get to that in a minute. So this is the web track again. And I wanted to be here today. I wanted to be at Scale in particular because I really think this conference is a lot different than a lot of the other conferences. So this isn't focused on platforms or APIs or anything like that. This is real engineers telling stories about how they were able to solve problems in the real world and more specifically at scale. So how do we actually scale something to hundreds of millions of users? And we'll hear a little bit about a bunch of different products and a bunch of different technologies. We found that, at least in my experience, when we work together and when we collaborate in the open, we can push technology forward a lot faster, a lot more effectively when we collaborate together. So I'm a huge fan of open source. We're going to talk a bit about open source today. We got a lot of great talks lined up. Ori's going to kick it off with Wikimedia, cutting wikipedia.com over to HHVM. Then we're going to have Ben and Pamela from Khan Academy talking a bit about interactive interfaces. WebP from YouTube. Mike is going to tell us a little bit about how YouTube is using WebP. And then we have Nicholas from Twitter, Paul Irish from Chrome, the Chrome developer team. And then we're going to have a Facebook talk from Avik and Jeff talking about JavaScript testing and type systems at scale. And then Jafar from Netflix is going to close it out at the end. I'm really excited about these talks. I think we have, the best part again is we have developers telling stories about, real world problems that are solved by a ton of different companies. After each talk, we should have time for questions, but we also have a Facebook group for those of you on Facebook, facebook.com/groups@scale2014web. You can go there, ask questions, continue the conversation there if you want. We'll keep the conversation going on Twitter with the @scale2014 hashtag. For those of you with an iOS device, there's also an @scale iOS app, so you can get the schedule and kind of follow along. Again, my name is Tom, but I'm really just here to hand it over to the speakers. So first up, we're going to have Ori come up here to talk about large PHP code bases, something near and dear to my heart as a PHP engineer, or as a Facebook engineer. We have a pretty large Facebook PHP code base too. So bring it on up, Ori.
Thank you. So should I be using this microphone, or should I simply?
Yeah, you're good. I just want to hand you that.
OK, great. So I'll start out by, first of all, saying how incredibly humbling and exciting it is to be here. There are such incredibly talented people, both in the audience and in the various tracks. And it's powerfully humbling and a privilege to have been invited to talk to you. How many of you have heard of a site called Wikipedia or have used it? Great. So what I'm going to talk about today is some of the scaling challenges that we've run into with the site. And I'm going to talk about how our migration to HHVM is helping solve them. The takeaways that I hope you get out of this talk are, let me put it differently. The audiences I'm addressing myself to are, number one, people who might consider actually migrating to HHVM. And my goal there is to persuade you that it's an incredibly exciting platform with a tremendous amount of promise for web development in general. And also to anyone who thinks hard and confronts with the problem of scaling websites on a day-to-day basis, and to sort of talk through some of the organizational psychology that shapes that kind of work. I will preface my slides by saying that I had something of a glitch earlier that ended up nuking part of them, so you'll notice the talk will become somewhat more hands-on and interactive in the latter half, but I'm inclined to feel that it'll actually be for the best. OK, so let's start. Great. So my name is Ori Livneh. I'm a senior performance engineer at the Wikimedia Foundation. It is a job that I've had for a year, and one of the really amazing things about the Wikimedia Foundation is that it puts people who are utterly unqualified for a position such as senior performance engineer at a top 10 website in such positions by dint of enthusiasm rather than necessarily accumulated industry experience. But that's actually, I'm joking, but I'm not joking. It really is a cool thing about us, and it's something that colors a lot of the work that we'll do, as you'll see in the slides. Wikimedia Foundation runs some of the most highly trafficked sites in the world, Wikipedia foremost among them, but a number of other reference projects as well, such as Wikimedia Commons, Wiktionary, Wikivoyage. Our infrastructure is built entirely on open source components, which reflects our pretty thorough commitment to free culture and free software movements and our rootedness in those movements. This means that our infrastructure is transparent to an astonishing degree. If we have time at the end, I'll show you how you can get very detailed metrics about every single server in our cluster and see the configuration of every server in our cluster without having to authenticate yourself or log in, and how you can even submit patches to that. We design and build everything out in the open. This means that there's, apart from tax forms and things like that, virtually all of our internal collaboration tools are built on top of MediaWiki and are publicly accessible. And they're not merely accessible in an abstract sense of if you were so inclined, you could go look at them, but we actively involve people from a very large community of volunteer contributors and volunteer software developers in our decision-making process. We have a fairly flat engineering culture. The distinction between not just engineering managers and engineers, but between paid employees of the Wikimedia Foundation and volunteer code hackers that submit code is very blurry. Some of our most, in fact, our most prominent engineers came out of a volunteer role for the most part, and it remains the case to this day that many of the most prominent members in the engineering community that maintains and develops the site are not actually employees, but are volunteers doing this in their spare time. And we prize diversity and consensus building. These things are strengths, but they are also limiting, and I would be remiss if I were not to mention that the focus on consensus building and on a flat engineering culture and the rigid adherence to using only and exclusively open source components sometimes limits both the choices that we have available to us in terms of software stacks and the agility with which we can execute decisions with far-reaching impacts because of the need to secure the consent of a very broad community of people. Our sites run on MediaWiki. MediaWiki is the collaborative editing software that runs Wikipedia. It serves content in over 100 languages to more than 500 million people each month. It comprises about 250,000 lines of PHP code and roughly an equivalent amount of JavaScript code. And one of the things that characterizes it most deeply is how powerfully extensible it is. So MediaWiki has, let me back up for a second. One of the things that has made MediaWiki a successful engine for a very broad reference project, such as Wikipedia, that contains such a dizzying array of content, is how extensible it is. MediaWiki has a very powerful hook system that allows extension developers to intercept essentially every operation and either abort it or modify it in various ways. That said, it does have some serious scaling challenges. These stem from the following properties. For one, the code base is 13 years old, and the age shows in various places. Much of it was written by volunteers with no access to the production environment. That has several consequences. So one of them is that the people who contribute code are often driven to do so by dint of having some domain expertise, often in a non-technical realm, or by dint of their community affiliation. So someone who is a musician might contribute an extension for rendering sheet music on Wiki, which is something that we actually have. So there is the 13-year history of the project is marked by a continuously expanding set of features and limited ability to exercise control over feature bloat in many cases. Wikitext itself, which is the markup language in which you write articles on Wikipedia, is massively complicated and not formally specified. It started out with the design goal of being a simpler alternative to HTML. I would argue that it's now actually substantially more complicated. The hook system that I mentioned earlier allows extensions to actually extend the parser by providing new types of language constructs, which is something that's utilized quite heavily. And the parser itself is implemented via a small army of regular expressions. We run over 150 extensions in production from A to Z, bringing the total number of PHP lines of code to about 1 million. And the tremendous power of the hook system comes with a price, which is hooks are a non-local control structure. And what I mean by that is they make it incredibly difficult sometimes to trace the control flow of a particular request as it winds through literally over 100 extensions, each of which can choose to intercept a process that happens internally in MediaWiki or not, depending on any environmental factors or whatever. And that makes it very difficult to reason about the performance characteristics of code. The developer community structure makes it hard to re-architect things. I talked about that a moment ago by characterizing many contributors as being primarily driven to contribute additional features, and also the commitment to consensus building as sometimes not enabling us to be very quick with drastic decision making. Other software projects that I've worked on have exhibited a greater degree of authoritarian structure, which can be tremendously positive when it comes to laying down ground rules for how we're going to pivot or how we're going to re-architect or how we're going to refactor something. The solution to the scaling problems are varied, but the most relevant one that I wanted to touch on is our heavy reliance on multiple layers of caching. We use Varnish, which is a reverse proxy and web accelerator. We were previously using Squid. We have multiple tiers. The outermost tiers use memory for storage. The layers behind them have persistent storage on solid-state drives. And as a result of that, 95% of requests are served directly out of the cache. Now, this is both a blessing and a curse. It's a blessing because it has really enabled the site to grow, and I don't think it would have survived without this infrastructure. The operations team for much of the site's existence numbered less than half a dozen individuals. To this day, it consists of less than 20 individuals, which is not a lot for a top 10 website. And the site is fast for 95% of requests. But as I said, it comes with a price, and the price is that the use of a web accelerator masks the performance problems of the underlying application. So if you know that the vast majority of requests are never going to hit PHP in MediaWiki, then you fret less about the performance characteristics of the code. And given that we have such a small number of engineers overseeing a very heavily used infrastructure, there's tremendous burden placed on code reviewers. And that tends to a performance standard of as long as you don't bust a cache, it's OK. And that has, over time, led to the creation of what you might call parallel universe, or you can pun and say cache fragmentation. What I mean by that is this. The easiest way to think about it, the way that I sometimes use to explain this, is we really operate two sites. The first site is the site that all of you who raised your hands earlier are familiar with, and that's Wikipedia for readers. That site has distinct software stack, distinct hardware, distinct user experience. It's powered primarily by Varnish. It consists primarily of static content, and its user base is close to 500 million people each month. But there is another site. That site runs on MediaWiki, Apache, PHP. It has a user base of about 750,000 active users each month, and about 1/10 of them are what we considered highly active editors. So these are people who make at least 5 edits a month. And that's fairly small. And one of the things that motivated me to consider HHVM when I took on the role, so when I first took on the role of a performance engineer, my focus, almost to the exclusion of everything else, was on front-end performance. Because I reasoned, if 95% of requests don't even hit PHP, then it doesn't matter what you do with the PHP code, with the back-end code, you're not going to have any impact at all on the vast majority of requests. But that's deeply misguided, I came to realize, because the 5% of requests that you do hit and that you do have an impact on represent the lifeblood of the site. They're the reason why the other 95% come. They comprise the sum total of content creation and content modification on the site. So it's vital to get that right. And one of the first numbers I looked at was the difference in page load performance between users that are logged in and that, by dint of having various customizations, are bypassing the Varnish layer and having their requests served by the Apaches, and users that are not logged in, that are anonymous, that get the site served from the cache. And the difference was pretty astonishing. So this is a somewhat dated graph. I'm happy to report that the situation is better now. But you can see there's a difference of about 300 to 500 milliseconds in the median page load time of anonymous users and editors. Now, editors in this particular context means something very simple. It's anyone who's logged in, whether or not they're actually in the process of making an edit or not. And this is horrifying because the way I think of it is it's like a customer loyalty rewards program that levies a penalty on the most dedicated users. So we effectively punish people for signing up and creating an account. And that's something that we have to fix. The reason it matters is the active editor population on English Wikipedia and on a number of other wikis is stagnating. After several years of dramatic growth, it's sort of flatlining. And we don't derive profit from conversions. So you might credibly ask, what difference does it make if perhaps Wikipedia is already comprehensive enough and the content is already rich enough? Maybe it doesn't need a particularly large base of editors to continue expanding it. But it is our mission as an organization to empower everyone to participate in the creation of culture. Because we do believe that everyone has something to contribute and that it can be a tremendously empowering and enabling political experience for people that we want to share. And in order to make that happen, it's imperative that we dissolve the hard distinction between readers and contributors. We need to make the transition between a passive consumer of content and someone who's actively contributing content be frictionless and enable new ways of contributing that don't require prodigious expertise in wiki text and so on. And to do that, we absolutely have to make the application layer performant, and we have to kick our addiction to caching. And that is what initially led us to examine HHVM. So I think many people in the audience are going, how many of you are familiar with HHVM? Okay, that's pretty good. For those of you that aren't, it's an open source virtual machine designed for PHP, developed at Facebook. It's a drop-in replacement for the Zen PHP interpreter. And the basic strategy that it takes to optimizing PHP code is predicated on the following assumption, which is that although PHP itself is a dynamically typed language, if you look at the way PHP code is actually written and executed, the variety of types flowing through the code are fairly static. And what HHVM does is it observes the types flowing through the code at runtime, and it generates machine code that is specialized to operate on these types, leading to substantial performance gains. Our benchmarks, our early benchmarks indicated roughly a 2x performance boost for MediaWiki. And so the last point is kind of funny. When I say the HHVM team shamed us into action, I mean that in the most positive way possible, which is the team developing HHVM at Facebook took it upon themselves to demonstrate how compatible PHP code is with HHVM by having the test suites of the major PHP frameworks pass under HHVM. And we were fortunate enough that MediaWiki is sufficiently commonly used that it was one of the frameworks that was chosen for this work. And so even before we were fully on top of it, we were sort of being confronted with like, hey, look, it's your code, it's the code that you wrote, and and the tests are passing. And this had a tremendously positive effect. It really sort of kicked the whole project into gear. So should express kudos for that. Some of the migration challenges that we faced. So one is PHP compatibility. I imagine that this would be foremost in the mind of anyone considering a switch. And I have to say, we were surprised by how astonishingly faithful HHVM is to the behavior of PHP 5, including pretty bizarre edge cases. There were compatibility gaps, but they were few. The ones we did encounter are surprising and painful. And to anyone who would consider embarking on a migration of PHP runtimes, there's a pretty good sort of litmus test or thought experiment that we've come to realize we can use in order to gauge the likelihood that an implementation of a particular feature in HHVM is reliable and well tested, and that's the likelihood that Facebook is using it. A silly but poignant example of this is, are you guys familiar with the PHP info, the function in PHP? Yeah, okay. So for those of you who aren't, it's something that you'd never want to use in production. It spits out a bunch of HTML that contains a whole bunch of server configuration data and PHP configuration variables and the number of loaded extensions. So the way it's implemented in HHVM is if you run PHP info, the output is simply hip hop, just a string, and that's it. You'd think that's not an issue, but using PHP info is a perfectly valid, legitimate way if you're logging onto a server for the first time and you want to get a quick sense of how it's set up to gauge that. So you do run into things like that. Some of the other things we ran into are the memcached driver didn't support a compression algorithm, which we were using in production, and since having a complete purge of the cache was not an option for us, we ended up submitting a patch for it. So yeah, those are some of the challenges that we ran into. The other big one was with PHP extensions. Now, by PHP extensions, I don't mean extensions to MediaWiki. I mean extensions implemented in C that utilize the Zend extension API. This is a common optimization technique for large PHP applications, namely to move hot code paths into C. HHVM provides a Zend compatibility layer, which exposes an API that mimics the Zend extension API. It was so-so when we started using it, but we actually contributed a number of patches to it, and it's pretty good now. But it doesn't solve everything. The biggest issues are not something that a compatibility layer can easily mask or solve for, because they stem from differences in the runtime threading model. So with PHP, and especially with mod FPM, you can assume that a request is executed in a dedicated subprocess. So there are various system calls that you can make in order to gauge resource usage of the current request context that refer to the calling process. So for example, the getOurUsage system call with the default parameter of, what is it? I forget, but yeah, right. Returns data about the calling process. And if you sort of uncritically use that as an indication of resource utilization of the current request, you will get it wrong, because the current process in HHVM, its lifetime spans many requests. So that is something that we ran into. PHP extension code is supposed to be thread safe, but often isn't. And HHVM will call you on it because it is properly multi-threaded. The other set of challenges were related to testing and Q&A. So once we got to the point where the tests were passing, we knew that there were other sort of edge cases lurking in there, but how do we expose them? And the way we did that, so you have a rough timeline up on the display, and that's by June, we were running MediaWiki's tests on each commit using Travis CI. By July, we sort of made the somewhat drastic decision to switch the Vagrant development environment that's used by most of our developers to HHVM by default. By July 23rd, we had the beta cluster migrated. The beta cluster is a fairly new piece of infrastructure for us, and that's simply a more or less faithful clone of the production environment on a more limited set of servers that are virtual, that developers and volunteers can use to test their code. And by August, we had a backend for HHVM and Varnish, and I'll talk about that a bit more in a second. I just want to give a sense of the effort involved, just because that's something that I wish I had at the outset of the migration process. This is the number of issues reported and resolved on Wikimedia's bug tracker that are tagged with HHVM for the period starting, that's actually, from June 2013 until September, and the data for September is obviously incomplete. What is telling about this particular picture is the rise in issues reported doesn't reflect the software being buggy, but simply more people using HHVM on a day-to-day basis and testing their code against HHVM on a day-to-day basis. And you can see that it correlates fairly well to the activity of our developers submitting code to upstream. So this graph shows the number of commits made upstream to the 3 repositories listed below by Wikimedia engineers for a roughly the same period. And you can see that it peaked in May and is now dwindling, which again is a positive indicator because it means that we're running into fewer and fewer issues that require upstream patches to fix. So outcomes. This is where, unfortunately, some of the slides that I had are gone, but maybe I could just demo it to you. There is a 50% reduction in page rendering time across the board. We often use the Barack Obama article on English Wikipedia as a default test case for performance measurements because it's incredibly complicated. It uses many features of Wikitext and so on. And the median time it took to preview or render the page went from 18 seconds to 7 seconds, or 61% reduction, which is amazing. And you can actually test it for yourself by setting a cookie, which I'm so going to get in trouble for making this public, but whatever. You know tech ops people, they're always cranky. You can't help that. So if I can get this to work, I have a tiny piece of JavaScript code. Is my internet on? Okay, so I have the, let me actually reset my cookies. Okay, so I have a tiny piece of JavaScript that extracts the backend rendering time and the engine used and display it at the top. And so if I go to edit source and if I preview the article, which causes this wiki text to be reparsed, I know. But actually, this is unusually slow. I blame the Wi-Fi. That's an important skill to have as a performance engineer, which is scapegoating factors outside of your control. So yeah, you can see that it took 20 seconds to render, which is, you can pick your favorite adjective from appalling, horrendous, terrifying. And what I'm going to do now is I'm going to set a top secret unguessable cookie. I should set the path to. Okay, and if I hit preview again, it's 6.9 seconds, which is, yeah, definitely better. Hmm? Yeah. So yeah, that's tremendously exciting, and you can test it yourself by setting the same cookie. And I wanted to reserve the rest of the time we have for Q&A if you have any questions.
Awesome. Thank you, Ori. Yeah, we have about 5 minutes, maybe a little bit more than that, for questions. So if anybody has a question, I'm going to come over and give you a mic. I think we also have a mic in the back as well.
Hi. I was wondering why you switched from Squid to Varnish.
I don't know the answer to that because the migration was already underway by the time we switched, but I suspect it had something to do with the complexity of the Squid code base. There is a by now fairly famous rant that's part of the Varnish documentation where Paul Henningskamp, I'm not sure I'm pronouncing his name, who's sort of the chief architect of Varnish, describes various ways in which Squid tries to outsmart the kernel by deciding on its own when to swap. And PHK sort of demonstrated, though not convincingly or convincingly depending on your perspective, that it ended up actually, many of its optimizations ended up having the effect of fighting with the underlying system and preventing it from being more efficient.
So one other announcement. We're going to actually, after every talk, we're going to have iPads that we're going to pass around. They're in the back there. You can see them. If you wouldn't mind just kind of rating each talk, just tap one of the things on the screen, either green, yellow, or red. You can kind of guess what they do. I think there might be textures on there if you're colorblind. I'm not sure. But just tap one of those and kind of pass it to your neighbor, kind of collection bucket style. Thank you. Next question.
On your hip-hop instance there, is caching then disabled or not implemented versus the PHP 5 testing you did?
Yeah, so you may have noticed that I was logged in both cases, and whenever you're logged in, because there are various preferences that you can set for customizing the interface, it has the effect of bypassing varnish. That's another question.
Question up here.
So as you get closer to rolling this out in production, can you talk a little bit about what kind of, are there any implications for what you're going to do with hardware or how you're going to deploy differently than what you have taking most of the traffic today?
Yeah, so I'll answer the second half of the question first, which are implications for our deployment process. So in order to squeeze maximum performance out of HHVM, you're meant to use something called repo authoritative mode. And what this means is that you have hip-hop analyze your code base and translate it into its intermediate representation before you actually execute it in serving real organic web requests. And when you enable repo authoritative mode, HHVM actually skips, if I'm not mistaken, checks that the source files were modified or not, and it just assumes that anytime you're going to modify the code, you're going to explicitly push a new bytecode repository, which it uses SQLite as a storage medium, so it's a SQLite file. We decided that the migration was already tricky and complicated enough without going that route, so we're not expecting to do that for the initial deployment. But I think it's nice to know that we have that option available, and it's sort of firmly planned for the next iteration. In terms of hardware, it's too early to say. I think it's likely to have pretty far-going implications. So one of the metrics that seems to be hugely affected by HHVM is memory usage. I think that we have 64 gigs of RAM on most of our web tier machines, and that seems excessive, far more than we need. And we're excited by the prospect of potentially using ARM architecture, which the HHVM team is working on pretty aggressively as far as I know. But it's too early to say at this point.
Okay, I think we have time for one more question.
So during the migration process, what was the most effective and least effective ways that you found bugs? Was it primarily through testing, or did HipHop tell you, hey, this is an incompatibility, you need to fix this?
It was largely, so it wasn't HipHop flagging things. It was having the same code in several cases on the same server be served by alternately PHP5 or HHVM made it possible to identify various incompatibilities. And one of the things we did is in addition to serving web requests, we also have, MediaWiki also has an asynchronous job processor, and we essentially had that iterate and parse every page on every wiki and diff the result against the one produced by Zend as a way of identifying incompatibilities.
Okay, I think we can squeeze in one more question. I think there was another one up here.
Did you notice any changes in the data access layer, like the way you interact with MySQL or other databases?
I think that's another one of those things that's going to become an area of focus once the initial deployment is complete. I suspect very strongly and have some evidence that our chronic reliance on caching means that there is a kind of, by now, ingrained allergy to computation. So for every piece of computation that needs to be performed, it's sort of wrapped by memcache lookup. And I think in many cases, the round trip time to get the result across the network link is not worthwhile. Possibly not even worthwhile under Zend, and certainly not worthwhile with HHVM. It's going to take a lot of painstaking benchmarking to identify all of that, though.
All right, awesome. Thank you so much, Ori.
Thank you.